Hi and Assalamualaikum. My name is Hanis Yasmin Sofia binti Hasmadi. My metric number is J22A0206. Firstly, I want to explain about introduction. Thermogravimetric analysis, iaitu TGA, is an analytical technique used to measure the change in weight of a substance as a function of temperature or time under control conditions. This method provides insight into material composition, thermal stability, and thermal degradation reaction. Next, the objective that we get from this experiment, first, is testing thermal stability, which is assessing the temperature at which a substance begins to degrade or undergo chemical change, and studying kinetic reaction, which is understanding the rate of change in weight of a substance as a function of temperature or time. Next, I want to explain about the purpose of the TGA experiment. The purpose of experiments using a TGA machine is to measure the change in weight of material as a function of temperature or time in a controlled atmosphere. This provides important information about the thermal properties of the material, including thermal stability, melting temperature, degree of decomposition, and composition of the material. In the context of wax analysis, TGA helps determine the decomposition behavior, weight loss due to evaporation or decomposition, and the remaining mass after the decomposition process is complete. This information is very useful for understanding the physical and chemical properties of material under various temperature conditions, which is important for industrial and research application.
Process. First of all, my name is Isanalangit Namina. So according to this video, thermogravimetric analysis is a technique used to measure the change in mass of the material as a function of temperature or times. Here a step-by-step explanation of how it works. Firstly, prepare a sample like a small amount of the sample placed in the sample holder. The initial wax of the sample is recorded. Next, the sample is heated at a controlled rate, for example 10 degrees Celsius per minute. The temperature can range from room temperature to over 1000 degrees Celsius, depending on the materials and the analysis requirements. After the sample is heated, then its wax is continuously monitored and recorded. The weight loss organ is plotted against the temperatures or time to produce a thermogravimetric curve. There also has atmosphere control on inert gas like nitrogen or argon is often used to prevent oxidation and the other reactions. Reactive gases like oxygen that can be used is the purpose is to study oxidation of the other chemical reactions. According to this figure 1, there is analysis result candidates. Firstly, we need to identifications of temperature range where the sample lose mass due to decomposition, evaporations, or the other process. The analysis process using the TGA machine starts with the preparations of a wax sample weighing 40.7999 mg, which was placed in a heat-resistant aluminum crucible and put into the TGA machines for further analysis. The TGA machines will gradually heat the sample while measuring its weight change at different temperatures. Thermogravimetric analysis is a technique used to measure the change in weight of a substance as functions of temperature or time under the control of Ftir. The data obtained from these machines is analyzed using star evaluation software to determine the thermal characteristics of the wax, such as melting temperature, level of decomposition, and thermal stability. So as we can see in this graph, the initial weight loss of moisture and volatile in the temperature range is 36.66 degrees Celsius to 350.52 degrees Celsius with weight loss of 25.06% as a mass loss of 3.71 mg and a midpoint temperature of 285.27 degrees Celsius. The main decomposition stage has a temperature range of 350.53 degrees Celsius to 791.75 degrees Celsius with a weight loss of 74.60%, a mass loss of 11.04 mg and a temperature midpoint of 422.96 degrees Celsius. The remaining mass after decomposition is 0.34% or 0.34 milligrams. This analysis provides important information about the physical and chemical properties of the wax under various temperature conditions. The information from this TGA analysis can help in understanding the burning characteristics of candle wax. Wax that decompose at lower temperature might have slowly burnt rates. The lower residual content imply a cleaner burns with minimal leftover materials, which is often desirable in candle production.
Finally, I want to explain about the conclusion. Good thermal stability, a clean burn with a little residue, and a significant weight loss during decomposition are all critical components in the production of high-quality candles. TGA analysis of the candle wax provide a detailed understanding of its thermal properties, including the decomposition temperatures, weight loss behavior, and residue content, quality control, and improving the formulation of candle wax to meet specific performance criteria. Benefit from this information. That's all from me. Thank you.
Next, Fourier transform infrared FTIR spectroscopy. The introduction is FTIR spectroscopy is a technique used to obtain the infrared spectrum of a sample. This technique works by measuring how the sample absorbs light at various wavelengths. It involves a Fourier transformation, which converts data from the time domain into a spectrum in the frequency domain. The experiment aims to identify the chemical components in the tested samples, measure the strength of chemical bonds within molecules, and study molecular structure and intermolecular interaction. In the field of science, FTIR is used in chemical research for qualitative and quantitative analysis, and it aids in the study of organic and inorganic molecules. In particular application, it is used in the pharmaceutical industry to ensure the purity and identity of substance, in the food industry to control product quality, and in the field of forensic for the analysis of evidence material. Of the experiment. First objective: identify chemical compounds. Determine the types of chemical compounds present in the sample by analyzing the produced infrared spectrum. Number 2, verify material composition. Ensure the consistency and purity of materials in production of research. Next, example of practical application. First, polymer industry. Analyze the chemical structure of polymer for product research and development. Number 2, verify polymer composition in the manufacturing process. Next, pharmaceutical industry. Identify active ingredients in drugs and ensure the consistency of production batch. Next, the procedure. First, sample preparation. Ensure the sample is dry and clean. Place the sample on a diamond plate or in appropriate holder. Number 2 is machine setup. First, turn on the machine and the computer. After that, open the FTIR software on the computer. Next, sample measurements. Position the sample for measurements. Run the spectrum analysis through the software. Wait for the sample spectrum to be obtained. After that, data analysis. Compare the sample spectrum with the spectral library to identify components. Analyze the spectrum peaks to determine functional groups in the sample. Last but not least is then wet a tissue or cotton swab with ethanol. Wipe the surface of the stage evenly and make sure to clean all surface that come in contact with the sample. Next, the procedure. First, sample preparation. Ensure the sample is dry and clean. Place the sample on a diamond plate or in appropriate holder. Number 2 is machine setup. First, turn on the machine and the computer. After that, open the FTIR software on the computer. Next, sample measurements. Position the sample for measurements. Run the spectrum analysis through the software. Wait for the sample spectrum to be obtained. After that, data analysis. Compare the sample spectrum with the spectral library to identify components. Analyze the spectrum peaks to determine functional groups in the sample. Last but not least is then wet a tissue or cotton swab with ethanol. Wipe the surface of the stage evenly.
The result. Figure 1 shows the result of FTIR. Using Omni software, the red line represents the spectrum displaying transmitted against one number cm-1. The software indicates a region associated with different financial groups. Allocated primary emitters around 3,300 cm-1 for NH stretch and 1,640 cm-1 for CO stretch. Allocated hydrocarbon around 2,850 is -2,916 cm-1 for CH stretch, and primary allocated alcohol around 3,200 -3,550 cm-1 for OH stretch, and around 1,040 cm-1 for CO stretch. This group suggests the sample contains CO and H2 group lone carbon chain and OC group attach a non-aromatic carbon. The spectral gradient of 4000 minus 2500 cm minus 1 adds head stretching variation to 105 for 1500 minus 4 cm minus 1. Figure free reference contain the main speed using identified functional group. Detail: any involved interface speed vary with regression spectrum analysis subtle and uses software tool for adjustments. The result 2 is figure 2. Array show the result of FTIR using Omni software. Various spectra are superimposed showing transmitted against one number cm-1. The red line represents sample spectra and other color lines indicate measures from no subtle libraries. The top measures include a silicon cellulose microscopy reflection and chipboard variant, suggesting the sample may contain cellulose-based material. Special phase for OH stretching 3200 minus 3550 cm-1, CH stretching 2800 and minus 3000 cm-1, and CO stretching around 1004 cm-1 cover a cellular structure while measured with a chipboard such as a lining or pendulum racing component. Supported by a repeat in the finger region 1500 minus 400 cm-1, detailed analysis involving identify speed accurately verified with reference spectra analysis speed intensity compared with no material and using software to like speed integration based concentration and disconvolution for improved analysis. That's all. The conclusion is FTIR using Omni software identify various Ftir group and compound in the sample. In figure 1 is speed of structure indicate the presence of alkylated primary amines, hydrocarbon and primary alcohol, suggesting a composition of CONH2 group long carbon chains and OH group a non-aromatic carbon. The figure 2 shows that the sample may contain cellulose-based material matching with cellophane, cellulose and chipboard variants. Bits for OHCH and CO structures confirm cellulose structure and suggest a lining or a phenolic resin component. That's all from us, Group Q. Thank you.